So we left off last Thursday. This was the assignment, page 372, 39 to 53 odd, derivatives of inverse trig functions. So 51. Oh, that looks terrible. 1/2, open parentheses, 1/2, natural log x plus 1 over x minus 1 plus arctan of x.
I have it written down as 3 through 9 and then 15 through 25.
That was Wednesdays. Yeah. Yeah, I remember we split that section into 2 days. The first section was pre-cal only stuff, and then Thursday was find derivatives. Okay. If I do this now, I'm going to have a mess right here. I mean, I guess I could do it. It'd be 1 over this times the derivative of that. But there's an algebra rule that will make my life a little easier. I'm going to distribute the 1/2. And then the natural log, remember we can split it in, if we're dividing logs, we can separate, whoops, I need a 1/4 on that one, with subtraction and make our life a little easier. Now, my guess is CalcChat's going to put everything back together in the end and get a common denominator, and we don't need to do that though. So y prime or dy dx would be 1/4 1 over x plus 1 times the derivative of x plus 1, which would just be 1. So chain rule, sort of, right? Chain rule always, but in this case the chain rule is just 1. Minus 1/4 1 over x minus 1, because that's the rule for natural log, 1 over the argument, times the derivative of the argument, and the derivative of x minus 1 would just be 1, so we're good there, plus 1/2, and then the derivative of arctangent is 1 over, let's see, there's not a square root on the tangent one, and I am 95% sure it's 1 plus x squared. Check my rules just to make sure. Wait, we just did that in warm-ups. Yes. The derivative of u over 1 plus u squared. So 1 over 1 plus x squared. Chain rule would be derivative of x is just 1. Now, to me, that's the answer. Thank you very much. We're done. Right? CalcChat is probably going to do all sorts of stuff to get a common denominator. And I don't want to do it, and I don't have to do it. So we'll leave it alone at that. Other questions from 39 to 53? 45. I see a quotient rule in our near future, because I think about algebra, I'd like to do algebra to get rid of it and make life a little easier or simplify things, but I can't do anything with that. So the top one's F, bottom one's G. G prime's easy. F prime, let's see, derivative of arc sine. Well, the derivative of all of them are 1 over something. Sine and cosine have a square root down there. The cosine one's negative, the sine one's positive. That's why we did warm-ups, right? Derivative of inverse sine is 1 over 1 minus the argument squared. So 1 minus 3u squared. And then times the derivative of the argument, so chain rule would be times 3. Oh, this is a little bit, I don't think you have a problem following, but this is a little bit weird because g of x is the overall function, and then I used f and g, but as long as you can keep it straight while we're going. Let's see, quotient rule. Gf prime minus fg prime all over g squared. So gf prime, whoops, that should be 1 minus 3x squared. I'm going to change it to 9x squared, square them both. So there's gf prime minus fg prime. That's the easy one, because 1 times arc sine of 3x all over g squared. And I don't know what CalcChat does from there, but the rest is algebra, so that's a safe stop. And I don't even know that, I mean, you could clean up by multiplying through by this square root, but it would clean up this fraction, but it would make this ugly and this ugly, so it's a safe stop and be done. But those were two good ones, because that was arctan. That was one of the questions, and then arcsine with a little bit of a chain rule thrown in. And so that was Thursday's lesson. Let's move on to today's stuff. It's antiderivatives involving inverse trig function. So it's a long title, but it's going backwards from what we did. It's basically using 5, 6, and 7 in reverse.